All right, so this is our last video for the last example, number 3, video number 4, learning target 10A. So we're going to be using the data values from example 1 again, as I mentioned in before. So please refer back to your notes from example 1. And so it's asking us, what is the standard deviation of the waiting times in each of the data sets? So this is a multiple choice question. So A is there's A, B, C, 7. So those are the two standard deviations that we should get. One of these is the answer to this problem. And so the data from office A is here and office B is here. Now, the good thing about us using the previous example, example 1, is that for standard deviation, we need to be able to find the mean. That's part of the process. So we're gonna be able to refer back to our calculations when we found the mean. So we'll look back at our notes in a second. But before we get there, I want to take us through the process of how to find the standard deviation. So step by step. So right here, how to find the standard deviation. Okay, so step 1, which is what we just talked about right now, we already found the mean. So you need to find the mean, okay? This is represented by the symbol. And then we already have this done, okay? This is from example 1. Okay, so in example 1, just thinking back. In example 1, we found the mean here for office A, which was 22 and 22 minutes. And in office B, we ended up with 16 minutes here. So we're going to use those two to find the standard deviation. Okay, so let me just write those back. So right here, the mean for office A was 22. And the mean for office B, we got it to be 16. Okay, so again, to recap, what we did to find the mean again, what's the process? You add them all up in the data set and then divide it by the total number of data values that are in there. So we got 22 here and 16 here. Okay, all right, step 2 now. What is the second step when you're finding the standard deviation? Well, once you have the mean from each one, then you go ahead and subtract each of these data values from the mean, and then you square it. So in other words, you're going to take 14, subtract it from 22, and then you're going to square it. Okay, so we're just going to write it out before we calculate it. 17 after that, minus 22 squared, 18 minus 22 squared, and so on. Okay, so we're going to do office A first, and then we're going to focus on office B afterwards. Okay, so in steps right here, again, second step, we're going to subtract each data value in the set. Subtract each data value from the mean. Okay, so again, we're subtracting one of these data values from the mean here. Okay, and then we're gonna square it. So don't forget to square it. All right. Once we do that, then we're gonna go ahead and do our third step, which is basically to divide our numerator. Once we subtract each data value from the mean for each of these data values, we're gonna go ahead and divide by the number of data values in the set, which is n. So divide by n, which is in this case the number of data values in the set. Okay. And last but not least, once we go ahead and divide by n, we're going to go ahead and find the standard deviation by taking the square root. So you take the square root to find sigma. And don't forget sigma, this symbol sigma is known as standard deviation. Okay, that's where we're going for here. All right, so again, there's 4 steps. So we're gonna recap what we're doing, but we're gonna show the work. So again, we already found the mean for each of these in example 1. So we wrote them down right here. So it's 22 for the first one and 16 for office B. Okay, so let's go ahead and find the standard deviation for office A first. So in order for us to do that, again, we're gonna use this right here. We found the mean. Well, next, step 2, we're gonna go ahead and subtract each data value from the mean, and then we're gonna square it. So again, this is an x, by the way, so x bar. Okay, so office A here, there's a general formula that we gave out in the beginning in the first page when we talked about the standard deviation. And so that was a measure of dispersion. So it's basically revolving around taking the square root of all the x's, which are the data values, and then you're going to subtract it from the mean. Once you subtract it from the mean, then you square it. So basically, in short, it's x1 minus x bar squared. And then now it's going to be the second value, data value in the set, minus, again, the mean. Then you square it, and then you keep going all the way into the last data value. So if there's 9 data values, then you're going to do this 9 times. In this case, we're going to do that because there's 9. So it's x to the sub n minus, again, the average, and then you square it. And then don't forget that the radical or the square root symbol is taking place all throughout this fraction here. And don't forget, we're dividing it by our n value, which is the number of n terms. So this is how you find the standard deviation by doing this process. Here it is in words, and here it is to help you remember it, or the steps of what you need to calculate the standard deviation. Okay, so from here, we're gonna go ahead and start getting these values. Okay, so our x1, again, we're doing office A here. My x1 will be here, will be 14. So we're gonna subtract it from the mean, which was 22. And then don't forget that you have to put it in parentheses because you're gonna square whatever you get from that answer. And then you can keep going all the way through all those numbers. So it's gonna be 17 minus 22 squared. So it's gonna be quite long, so extend your radical symbol as long as you need to. And then plus, the next one is 18. So it's 18 minus 22 squared. Then we have 19 minus 22 squared. So again, we're looking up here. Then we have 20. So this is my 1, 2, 3, 4. This is my 5th data value. So it's 20 minus 22 squared plus, then we have 24 twice. So let's go ahead and extend this square root symbol. So it's going to be 24 minus 22 squared, 24 minus 22 squared, since there was 2 of them. And then we're almost there. We have 30 and 32. So we're going to go ahead and subtract 30 minus 22. And then last but not least, the last one was 32 as a data value. So it's going to be plus 32 minus 22 squared. And don't forget to extend your data value. So it's 32 minus 22 there. And then all of this, yeah, it's quite long. We're going to divide it by our n value. So in this case, our n value here is 9 because there's 9 numbers in our data set. Okay, so we're going to divide this by 9. And don't forget, this whole fraction is inside the radical symbol. Okay, so from here, we're going to do some simplification here. So we're going to have 14 minus 22 gives us negative 8 squared. This next one gives us 17 minus 22 is negative 5 squared. And let's keep extending this here. Then it's 18 minus 22 squared. It's going to be negative 4 squared. 19 minus 22 gives us negative 3 squared. 20 minus 22 is negative 2 squared. 24 minus 22 is positive 2 squared. And we have that twice, so we have another 2 squared. Then we have 30 minus 22 here gives us 8, so it's plus 8 squared. Extend this more, and last but not least, 32 minus 22 is 10 squared. Okay, be very careful with the calculations here because I know there's quite a bit. And then don't forget, we're still dividing the whole thing by 9, which is the end value, the number of data values in the set. All right, so from right here, again, it's just order of operations here. We're going to simplify the numerator of this big fraction. So it's going to be negative 8 squared is 64, negative 5 squared is 25, 16, 9, negative 3 squared is 9, negative 2 squared is negative 2 times negative 2 is positive 4, 2 times 2 is 4, same here, and 8 times 8 is 64, and then 10 squared is 100, 10 times 10, and don't forget you're dividing this whole thing by 9. Okay, from here, just going to go to the right side. And from here, we're going to go ahead and, again, you can add them up by hand. I'm going to use a calculator real quick. When you use a calculator here, you're going to end up with the square root of, this will all add up to 290. And then we're going to divide it by 9 here. So this right here, we're going to use the calculator. It's going to be an approximate data value. So this little symbols here, squiggles, call them the squiggles. It's going to be approximately 5.7. So my standard deviation here is approximately 5.7 for company, sorry, not company, for office A. Okay, so again, this tells you how dispersed it is from the mean. So if the standard deviation is big, then that means it's not, the data is not as accurate compared to the mean. And the closer it is to 0, then it's much more accurate and closer to the mean. Okay, so now we did that for office A. So we have to do the same process for office B. So notice that answer A is already out of the question since we don't have, we just got approximately 5.7 here. So this one's definitely out of the question. We have 5.7 here. We don't have 5.7 here. So C is out. And we have 5.7 here. So it's either going to be the letter D with the 4.5 or 5.2. Okay. All right. So we have a 50-50 chance if we needed to guess, but we don't need to guess. Okay. All right. Now, in the bottom here, we're going to go ahead and try to squeeze in here our office B. And again, we're going to be repeating the process. So this time we're going to use this data set here. So we're going to use the mean that we found in the first example, which was 16. Okay. All right. So again, using the same steps, we're going to write our average, or our mean was 16. And my end value here, since again, there was 9 values in the data set, so it's 9. So we're going to use this to substitute into this general formula. But again, we're going to be subtracting our data values from the mean and then squaring to get the numerators. Okay, and we're going to do this 9 times again. All right, so right here, big radical symbol. I'm going to use a different color here. I'm going to extend this all the way through. And we're going to start out with our first data value, which is 8. So 8 minus 16 and then squared. 8 minus 16 squared plus, next one, 11 minus 16 squared. 11 minus 16 squared plus the quantity of 12 minus 16 squared. Okay, so again, all we're doing is finding the data values and then subtracting it from the mean, and then we're squaring it. Okay, so our next one is 16. So 16 minus 16 squared 18 minus the mean, 16 squared. And then we're doing that actually two more times. So we're gonna do 18 minus 16 squared plus 18 minus 16 squared. And then after the last 18 here, we have two more to go, 20 and 23. So let's do 20. So it's 20 minus 16 squared. So right here, we're gonna put 20 minus 16 squared plus, and then a quantity of 23. 23 minus 16 squared. And don't forget, we are extending this big old square root. Okay, so as you can see here, it's quite long. And then we are gonna divide this whole thing by our n value, which is 9, because we have 9 data values in office B. Okay, so we're gonna divide this whole thing by 9. So you might want to make this a little bit more obvious that this is all inside the square root symbol. Okay, all right, and then from here again, we're gonna go ahead and simplify the numerator. Okay, so sigma is equal to big old square root, and 8 minus 16 squared gives us negative 8 squared. 11 minus 16 gives us negative 5 squared. 12 minus 16 gives us negative 4 squared. 16 minus 16 is 0 squared. 18 minus 16 is 2 squared. And we actually have that 2 more times, so 2 squared 2 more times. Then we have 20 minus 16, which is 4, so it's 4 squared. And then 23 minus 16 is 7 squared. And then all of this is divided by our n value, which was 9. Okay, so when we simplify this in the numerator, get sigma, which is the standard deviation, is equal to radical, or the square root of 64. Negative 8 times negative 8 is positive 64. The quantity of negative 5 squared is 25. Negative 4 squared is 16. 0 squared is just 0. 2 times 2 for 2 squared is 4. Same here. 3 times 2 times 2 for these. 4 squared is 16. And finally, 7 squared, 7 times 7 is 49. Then you're going to divide the whole thing by your n value, which is 9. All right. Now, when you calculate this, we're going to go ahead, and you can, again, do it by hand. I'm doing it with a calculator just to be a little quicker. When you add the whole numerators here, all the 64 all the way to the 49 in the numerator here, you're going to end up with 182. And then you have 182 divided by 9. When you insert this in the calculator, your answer is going to come out to approximately 4.5. Okay, so that means that for office B, your standard deviation is for approximately 4.5. And don't forget, this is 4.5 minutes, since we're talking about in minutes. And this one is in minutes as well. Okay, so to conclude, so we got 4.5 for office B and 5.7 for office A. So notice here in the top that it's going to be letter D, 5.7 and 4.5. So you're going to go ahead and circle that, and you have the work to prove it, okay? So that's what it takes to find the standard deviation. Again, it's a lengthy process, but again, once you have a little bit of practice, you're going to be all set. And then again, this is very important in terms of when you're looking at statistics in the real world and comparing and using that data to compare it to, for example, the mean, to see how dispersed it might be, how far away or closer it is to the mean, to see if the data is accurate, and if it's not accurate as well. Okay, thank you very much. Hopefully you enjoyed the videos. We're done with learning target 10A. Thank you. Bye.